Hi! This video will provide a deep analysis of Hawkeye, a credential-stealing malware being sold as malware as a service. We will provide this analysis using Cyberbit EDR, endpoint detection and response platform. Hawkeye is a fileless attack. Therefore, it often evades signature-based detection products. By using Cyberbit's behavioral analysis, we will detect it and demonstrate how an entire attack is executed. This is Cyberbit's behavioral graph view. This graph was created after detecting and analyzing a potential Hawkeye attack. Red nodes indicate suspicious behaviors, like this code injection. Hawkeye works by using keylogging on the target endpoint and uses a free tool which is contained in an encrypted resource section of the binary to extract sensitive login data from web browsers. First, the malware attempts to schedule a Windows task, so it will execute each time the user logs in. This way, it achieves persistence. EDR has detected the suspicious behavior. We will now click on this behavior to dive deeper. We can see that the scheduled task was configured by an XML file, which is posing as a temp file tmp-ddh2.tmp. This XML file contains the configuration details allowing to schedule the Windows task. This activity looks suspicious, so we will now dive deeper into the raw event data related to the Hawkeye executable that triggered this behavior. We can also see all the files that were used by the malicious file during the initial phase of the attack. For example, we can see that it accessed many files such as sysmain.sdb and ahronbd.tff. Here, we have identified the malware performing two suspicious operations. It creates a reg-asm process. Reg-asm is an assembly registration tool which is a legitimate Windows subsystem process. Next, it injects malicious code into this process by using the setThreadContext technique. Running the malicious code as part of a legitimate process is a stealthy way for the malware to look legitimate and bypass whitelist applications, as well as unskilled analysts. The reg-asm executable now uses reflective DLL loading to load an external library without having to store it on the hard drive. This is a fileless approach, intended to reduce the malware's footprint. Cyberbit EDR also allows the analyst to fetch the memory dump of the process to analyze the injected executable using third-party tools. The executable now enables keylogging on the machine. The keylogging technique uses a setWindowHookX API in order to receive any key pressed and store it and later send it to a command and control server. After enabling keylogging, Hawkeye performs additional actions to steal passwords. Here we can see that it injected code into VBC executable. VBC executable is a signed Windows executable that works with .NET Framework. Once again, the malware uses code injection to run as part of a legitimate Windows process and evade security tools. Hawkeye now uses two injection techniques: setThreadContext and process hollowing. Process hollowing is an interesting technique that loads a foreign process to memory in suspended mode, replaces the code of the process in memory with malicious code, and then resumes it. The compromised VBC then performs two malicious actions aimed at stealing data, such as passwords from web browsers. It accesses ELSAs, the Windows authentication service responsible for storing and handling all Windows authentication data. In this case, the malware steals NTLM credentials, which can later be reused for techniques such as pass the hash in order to log into additional computers and perform lateral movement. It accesses sensitive files, in this case, Chrome login data. Chrome stores all credentials in this file. Surprisingly, Chrome only obfuscates the data, but does not encrypt it. Therefore, the malware can easily extract the passwords as plain text. This summarizes Cyberbit EDR analysis of Hawkeye. Cyberbit EDR was able to detect, analyze, and visualize extensive use of evasive processes and fileless memory-based techniques, including reflective loading and utilization of legitimate Windows processes. These behaviors were displayed as a graph described in clear, spoken terms. Thank you for listening, and feel free to contact us on www.cyberbit.com to learn more.